Welcome to Train Signal. You're watching a video about Active Directory Certificate Services. In this video, we are going to talk about all the different components that would be used to form something called a PKI. Now, PKI stands for Public Key Infrastructure, and Active Directory Certificate Services is the role that you would use to implement your own PKI. But in order to do any of this, you need to have a full understanding of all the different components. So, some of the components that we're going to look at are certificates, certificate authorities, or what's for short just referred to as CAs. Okay, it's a lot easier to say than certificate authority. We'll take a look at the different type of CAs, talk about how to get a certificate from the CA. We'll talk about enabling credential roaming. The CRIL, the CRIL, which is really just CRL, is a short way of saying the Certificate Revocation List. And then we're going to talk about something that is new to Windows Server 2008, which is something called the Online Responder. Now, after we talk about all the different components, I will then go into the operating system and show you how to install and configure the Active Directory Certificate Services role. So, what is a certificate? That's the very first component for us to talk about. Well, a certificate, to keep it real simple, it's a form of ID. Okay, it's like an identification card. It's used to identify different entities. Now, these entities can be users, they can be computers. Okay, one way that you might be able to think about it is when you go to a secure website. A certificate is used to be able to validate the true identity of that website. Now, certificates are issued by a certificate authority. And we'll talk about the certificate authority, or the CA, in just a few minutes. The certificates themselves contain information about the entity, and then also about its issuer, about the CA that issued the certificate. Now, certificates generally are not indefinite. They do have an expiration date, and they can also be revoked prior to expiration if we see that there's a reason to invalidate that certificate. But we'll talk about that in a little bit. Now, the thing I like to do to help me understand exactly what a certificate is I like to analogize it with my driver's license. And I will tell you, before I give you the description as to how this analogy works, there's other components in the PKI that you still need to understand. But after we go through all the components, we'll come back and we'll see how there's great similarities between certificates and driver's license. Now, one of these other components would be the certificate authority, or what's more simply put, CA. It's a lot easier to say just the two letters CA, so that's why you'll hear most people doing that. Now, the CA is a trusted third party whose primary responsibility is simply to validate the identity of the entity requesting the certificate. So, if a user wants a certificate, that user is going to have to go to a CA and prove exactly who they are through some other form of identification. Now, once the CA has indeed been convinced that you are who you say you are, well, then the CA will issue you a certificate. Now, there are different types of CAs, and I will tell you that there are two primary types that we can talk about, and that would be either external or internal. And one of the first things to keep in mind is when it's appropriate to use an external and when it's appropriate to use an internal. Well, I'll tell you, more often than not, it's appropriate to use the external. And the reason why is because anytime you're going to need somebody from outside of your organization to be able to validate something or somebody within your organization, you're going to need to have somebody who's not part of your organization be the trusted third party. Okay, see, if I issue a certificate to myself, and then you come to me and say, you got some ID? And I show you my certificate, and my certificate says that I basically gave it to myself, well, what reason do you have to believe that certificate? I mean, I remember when I was a teenager, and the big thing to do was to create a fake ID that you did all by yourself. Well, if you issue yourself an ID, it doesn't do a whole lot of good. So external CAs, sometimes known as public CAs, are what you will use anytime there's going to be an interaction between you and somebody outside of your company. Or really, I should say, an entity within the company with an entity outside the company. Now, just to kind of put a little clarity here, the most well-known public CA is a company called VeriSign. This is a company that has been around for a good many years, and their sole purpose in life is issuing certificates, validating who you are, and then issuing you a certificate. If you've ever gone to a secure web page, or if you have ever downloaded some software maybe from a website and you had a window pop up and you saw the VeriSign name in that window, what you were seeing was that certificate validating the identity of the provider of that information. Now, besides the external CA, we also have internal CAs, and the internal CAs are done through Active Directory Certificate Services. And when you implement Active Directory Certificate Services, you have 4 options. You have 4 different types of CAs that you can create. You have what's called an enterprise root, and I'll tell you what, you'll notice that 2 of the CAs here say enterprise and 2 of them say standalone. And then you'll notice that 2 of them say root and 2 of them say subordinate. So really what we need to do is define the word enterprise versus standalone, and then define root versus subordinate. Now, enterprise means that you are going to be functioning within Active Directory domain services. So things will be validated within Active Directory domain services. And standalone root, or we'll even just say standalone for the moment, standalone means that you are going to be installing the CA on a server that is not going to necessarily coordinate with Active Directory domain services. So kind of the easy way to remember it is enterprise goes with Active Directory domain services, standalone does not go with the Active Directory domain services. Now, as far as the term root versus subordinate, well, CAs can be implemented to form a hierarchy. And this is done for the purposes of security, really. And in just a moment, I'm going to show you an example of a hierarchy of CAs. But the root is pretty much the top level CA. And it has what's called a self-signed certificate. So a root CA is going to issue itself a certificate, which is going to pretty much be a certificate saying that I am a CA. And, it is because I say so. And that's why it's really important that these CAs be a trusted party. Now, a subordinate CA would be a CA further down in the hierarchy, which receives a certificate from the root CA. Here, let me bring up a diagram to help show this. Here I have a diagram of what I think is a somewhat typical CA hierarchy. See, up here at the top, you'll see here that we have a root CA. Now, don't pay attention to the fact that it says offline root CA. I'll talk about that in just a moment. For right now, it's a root CA, meaning it's at the top and it gives itself what's called a self-signed certificate saying, I'm a CA and I can issue certificates. So I kind of establish all my own rules. Below that, you'll see that we have a couple of subordinate CAs. Now, these subordinate CAs are going to receive an issuing certificate or a CA certificate from the root CA. Okay, so basically, these 2 boxes, they are also going to be CAs, but they don't make the rules. They get the rules from the root. Okay, so the root has issued them a certificate acknowledging that they too are a CA. Now, some organizations stop right there, and the subordinate CAs, as they are listed in this picture, okay, so at this level right here, they are the quote-unquote issuing CAs, meaning the clients actually go to these CAs to get certificates. But I've taken this hierarchy just a little bit further. See, I have an extra layer to my hierarchy, and here, although these say issuing CA, okay, these all say issuing CA here, these are also subordinate CAs. The only reason I called them an issuing CA is because that is their main purpose, is to go ahead and communicate with all the clients out there looking for certificates. So basically what happens is the issuing CAs, of course, get their certificate from the subordinate CA above them. And then when the client gets a certificate from its issuing CA, okay, so we can say this goes on out to a client computer. We'll just draw a little client here, right? Just a little person. We'll say this person is looking for a certificate. All right, so this person gets a certificate from the issuing CA. What ends up happening is that certificate will have information about the CA that gave the certificate and pretty much the hierarchy leading all the way back up to the root CA. And the reason why is because, again, the root has to be a trusted entity. Okay? Since the root assigns its own certificate and is the beginning of the whole thing, it must be a trusted source. Now, here's why we create a hierarchy. I mean, you might be thinking to yourself right now, well, wait a minute, let me clear this out. Why didn't the offline root just go ahead, or why didn't we just create the one CA and issue certificates and be done with it? Well, you can. But the problem there is if somebody were to, let's say, hack in and compromise this CA, well then all of the certificates that this CA issued would also be compromised. And then what you would have to do is pretty much delete it and start all over again. Now in the scenario that I've drawn out here, if this issuing CA were to become compromised, all we'd have to do is pretty much revoke, and I know we really haven't talked about revocation yet, but revoke the issuing CA's certificate. Okay, so pretty much up here at this level, the subordinate CA will basically take this issuing CA's certificate away, and by doing so, all of the certificates that it may have issued out will also no longer be valid. Now in this instance, we would not have to completely recreate our whole PKI. All we'd have to do is go ahead and reissue a new certificate to the issuing CA, right? Because that first one was compromised. And then the issuing CA could go ahead and issue out all of its certificates all over again. A lot easier. Now to take this a step further, the reason that I went ahead and took the root CA offline is because the reality is that although the front line really are the certificate servers that are at risk, they're highly susceptible to attack, a good attacker might even be able to move up higher in the hierarchy. And basically, if that attacker makes it all the way up to the root CA, well then you're going to have to start the whole process all over again. So by taking the root CA offline, meaning you truly just flat out turn the computer off, unplug it from the network, stick it in a closet somewhere, I don't care what you do with it, but by making it not part of your network, by taking it offline, it is not susceptible to attack. So basically what you do is you go ahead and you roll out your root. You have that root go ahead and issue out the two certificates to the subordinate CAs, and then you go ahead and take this guy offline. Stick him in a closet somewhere. And then everything in your PKI is pretty much being managed by these CAs. Okay? And that way, only these 5 CAs are at risk. And even if, worst case scenario, if all 5 of these CAs were to be compromised, or we'll even say just these 2 CAs, the 2 subordinate CAs were compromised, which means obviously if they were compromised, everybody they issued certificates to, meaning the issuing CAs, was also compromised, which means everybody they issued certificates to is compromised. Even if that were to happen, worst case scenario, all you would have to do is go ahead and bring your root CA back online. Okay, so bring it back online, revoke the 2 certificates that were issued to the subordinate CAs, and issue 2 brand new certificates, and then go ahead and take it offline once again. And then, of course, the subordinate CAs will issue their certificate out to the issuing, and the issuing will reissue their certificates out to all the clients. This is why we create a CA hierarchy, and this is why we have root and subordinate CAs. So, how do I get a certificate? Now, we'll look a little bit at this when we go into the operating system, but basically there's 2 primary ways to do this. You can do it through something called auto-enrollment, where certificates are distributed using templates. And you use these templates so that you hopefully do not have to require user intervention. Now again, this is going to be only in an internal environment. If you are going to an external public CA, there's no auto-enrollment. You're going to have to go through whatever measures that public CA asked you to go through, whether it be providing address and phone number, maybe officers of the company, write a letter on letterhead. There's all kinds of things that have to be done to validate who you are to a public CA. Auto-enrollment is something you can do in an internal PKI environment. Now, the other primary form of enrollment would be web enrollment. And with web enrollment, this allows a user to submit a request for a certificate through a web browser. There's actually a URL to the CA where there'll be a little form that you fill out with your information, and then that request can go to the CA, and then a certificate manager can go ahead and look over the information and decide whether to issue the CA out to you or not. Credential roaming. Credential roaming is kind of an awesome thing. Certificates can be stored within the Active Directory Domain Services database to allow for this credential roaming. The reason for putting it out in Active Directory is so that users can access their certificates from any computer within the domain. So whether the user is logging on here, or whether the user is logging on down here, or wherever the user may be logging in, it doesn't matter, because when they log in, they will get access to their certificate from the Active Directory database. Now, where this is most commonly seen is with something called EFS, the encrypting file system. The way EFS is done is through the use of private and public keys, and the public keys are actually stored in certificates. And so the idea is a user can log into one computer on the network and encrypt something, and then maybe at a later date they log into a different computer on the network, and well, they want to get to their file that they encrypted. Well, in order to do so, they're going to need their certificate and matching private and public keys, and they can do so by having something called credential roaming. All right, well, we finally made it back to this. I mentioned way back at the beginning, matter of fact, I mentioned a couple times about the concept of revoking a certificate. Anytime a certificate is no longer valid, it can be revoked. Now, there's many different reasons why a certificate might be revoked. I mean, like I said, the certificate might be compromised, the CA that issued the certificate might be compromised, or pretty much any reason you can think of that the certificate can no longer be trusted. I mean, I've seen scenarios where people have gotten away with using other false information to prove their identity. Believe it or not, there was actually a very brief moment. This was kind of a big mistake, but one that was corrected very, very quickly. There were a couple of guys out there who, some way, somehow, I don't know how they did it, but they convinced VeriSign that they were Microsoft. So VeriSign actually issued certificates to these guys so that they could say that they were Microsoft. Well, it became known fairly quickly that these certificates were not valid and that these guys were not really Microsoft. And so what VeriSign did was they just went ahead and revoked the certificates because they knew that they were not to be trusted. The certificate revocation list, or CRIL, is used to publish information about the certificates which have been revoked. See, every time a certificate is used, it is checked against the CRIL to see if it has been revoked. Okay, so the point is, even if some entity has their hands on a certificate which says that they are somebody or something, if you check to see that that certificate is valid, in other words, you check against the CRIL, that's how you can truly know, is it okay to trust this entity? Okay, so that's a very important step, by the way. Because if you don't check it against the CRIL, well, then you don't know. You don't know if the user is who they say they are or the computer is who it says it is. Alright, before I go any further, let me see if I can explain the whole driver's license certificate analogy to you. Now, I know this is going to be a little bit different depending on exactly where you live. But I live in the state of Illinois in the United States of America. And, let me go back through the screens here, and we'll go through each component and see how it's similar. Now, here in Illinois, I can use my driver's license as an identification card. And again, I know this is going to be a little bit different depending on where you might be, but I can use it as an identification card. And that part's really easy to understand, right? A certificate is an identification card, and my driver's license is an identification card. But we also said that a certificate has information about me, and, well, my driver's license has information about me. My driver's license has my name, my address, my height, weight, hair color, eye color. And then we said that a certificate has information about the issuer. Well, my certificate says that it was issued by the state of Illinois. Actually, more specifically, by the Secretary of State of Illinois. My driver's license is signed by me, and my driver's license is signed by my issuer. Certificates have an expiration date. Well, my driver's license has an expiration date. We say that certificates can be revoked, and my driver's license can be revoked. Okay, so there's a lot of similarities. Now, if I go a step further, well, where do I get my driver's license? Well, I get it from the Secretary of State. Okay, so that's how it's done here in Illinois. And what I need to do is I need to go to one of the offices of the Secretary of State, which would be like the certificate authority. And what they do there before they issue this driver's license to me is they have me prove to them who I am. Okay, so again, this might be a little different depending on where you are. But here, what I had to do, back when I was 16 years old, I had to bring other forms of identification to the Secretary of State's office. I had to bring my birth certificate, social security card. I actually don't even remember the entire list. But when you walk in, right up on the wall, they give you a whole list of, here's what you need to bring to us to prove that you are who you say you are before we're going to issue that identification card to you. Okay, so there again, the certificate is a lot like my driver's license. Now, as I mentioned a moment ago, my driver's license does have an expiration date, but it can be revoked at any point in time by the issuer, by the Secretary of State. Now, where this is very similar to the CRIL is if you think of it as if my driver's license has been revoked and I still have a physical card in my pocket, right? They've actually given me the physical driver's license. If I present that driver's license to somebody who's asking for identification, and they look at it and say, all right, right, that's all they do. Well, I'm going to get away with whatever it is that I'm trying to do with that identification card. But if they were to check it against a database of revoked driver's licenses, then they would know that it was revoked and would not allow me to use it as my identification. So an example I might give is if I go to the liquor store and they ask me for my driver's license to prove how old I am, to prove that I'm old enough to purchase liquor. And they just look at the card and that's it. Well, there you go. I'm going to get my liquor, whether it's legitimate or not. Whereas, let's say I get pulled over by a police officer, and that police officer takes my driver's license to the car and pulls up on the computer to see if it has been revoked, and if it has, well, then I'm not going to get away with using that as my identification. And pulling it up on the computer is kind of like checking the CRIL. Okay, checking the certificate revocation list. And this is what I do anyway to help me to kind of understand the whole big picture on what a certificate is and how a PKI works. Now, let's talk about this new thing called the Online Responder. And I say new thing because it's new to Windows Server 2008. Now, an Online Responder is used to help make the process of validating a certificate more efficient. Now, how does it do this? Well, previously, the entire CRIL would have to be downloaded to the client in order to check the validity of a certificate. And believe it or not, the CRILs could get to be quite large. So it really could use up a lot of bandwidth, and it wasn't very efficient having to download the entire CRIL. The Online Responder is something, well, first of all, the Online Responder is something that you will install on, we'll say, it's like a middleman. Okay, the Online Responder is who the client will communicate with, and the Online Responder will then check only information about the specific certificate in question. In this way, the entire CRIL no longer has to be downloaded out to the client. Only the information about that one certificate needs to be sent to the client. And this is a pretty cool concept because this will help speed up the whole process of using certificates. And I will tell you, that in itself is reason alone why certificates were not used more often than they probably should have been. Okay, so we can at least alleviate that one problem with using certificates. All right, well, enough of the chit-chat about the components of a PKI. We need to get in and take a look at installing Active Directory certificate services. So let's go do that now. For this demonstration, let's go ahead and connect with New York Member 1. This is a Windows Server 2008 computer which is fully capable of being a CA. Now, I will tell you that we are going to create an enterprise root CA on this particular server. And that's pretty much all we're going to create. We're not going to implement an entire PKI here on the Global Mantix network. And the reason we're looking at this from more of a conceptual point of view is because, quite frankly, every internal PKI tends to be pretty much unique. Okay, so in other words, in order for you to be successful in being able to set up a PKI for your network, you have to have a good firm understanding of the components, which is what we just went over, and you have to then know how to navigate through the interface, which is what we're going to do now. So, with that being said, let me go ahead and click on Start and select Server Manager. And the reason why is because we need to start off by installing the Active Directory Certificate Services role, and we install roles through Server Manager. So let me click on Roles, and then click on Add Roles. Now you'll see here right at the top, Active Directory Certificate Services. So I'm going to check that box. And you'll see here it takes just a moment while it goes through and comes up with the rest of the wizard, because there's going to be a lot more to this, as you can see over here on the left. And then I'm going to click Next. It takes us into an introduction into what Active Directory Certificate Services are. So I'll click Next again. Here I have a choice of different role services, and you'll notice the very first one is to be a certification authority. Certification authority, certificate authority, same thing. We could be a certification authority for web enrollment. Okay, so if we want to do web enrollment, we need to check that box. You'll notice that when we check that box, there's additional web services basically that are going to be required. So I'll go ahead and say add those as well. If I want to be an online responder, I can check that box. I will tell you that if I had not selected to be a certification authority with web enrollment, the online responder probably would have prompted me for additional web services as well, because IIS is a requirement to be an online responder. And then I also could select network device enrollment service, and this has to do with being a CA for different networking devices like routers and things like that. But we're not going to worry about that part for right now. I'm just going to check these three boxes and click Next. Now it's asking me what type of CA I want to be. Do I want to be an enterprise or a standalone? You'll see here that an enterprise would be a CA that's a member of a domain and can use directory services to issue and manage certificates. As I said before, enterprise associates with Active Directory, whereas a standalone would be a CA that does not use directory services to issue and manage certificates. So I'm going to go ahead and select enterprise, click Next. Now you'll see that I need to choose between root or subordinate. Now because there is no root out there yet, that's the only choice I have. If there was already a root CA, well then I could choose to make this a subordinate CA, at which point I would have to point to the root. So I'll select root CA, click Next. If I already had a private key, meaning if this was a CA that was previously created and I was just reinstalling the CA, then I would use the existing private key. But because this is a newly created CA, I have to have a new private key. And click Next. Here you will see that there are a number of different cryptography schemes that you can use for the creation of this CA certificate. We're not going to worry about the actual cryptography right now, so we'll just go ahead and take the defaults and click Next. Now I need to give this CA a name. And you'll see here it says type in a common name to identify this CA. This name is also going to be added to all certificates issued by this CA. So I want this name to be something that would make sense. So I might say something like, I might leave GlobalMantics, but then maybe say Enterprise Root CA. Maybe that would be a good name. As a matter of fact, let me go ahead and let's capitalize GlobalMantics there, right? All right, so there's a common name. It's the GlobalMantics Enterprise Root CA. Click Next. Now I need to give it an expiration. Now remember, all these things will be set by the issuer whenever you're getting a certificate from a CA, but because I'm the root, I have to establish my own CA, so I need to go ahead and select a period. I'll take the default of 5 years. Basically, the validity period will have to do with whatever your scenario may be and what seems appropriate for when you would want to completely revamp the system. So we'll just take the default of 5 years and click Next. Here it's asking where do you want to store the certificates, so we'll just go ahead and keep it in its default location. Here it's now taking me to the web services that have to be installed, and for this I'm just going to pretty much click Next right through it. This is just allowing me to see all the different required IIS components that we have to have. So I'll click Next, I get a confirmation, and I click Install. And now it's going through the process of installing not only the Active Directory Certificate Services role, but the Web Server Services role, or at least the role services of the Web Server Services that needs to be installed. This can take a few minutes, so I'm going to go ahead and pause the video, and I'll come right back with you as soon as it's complete. Okay, as you can see here, the installation has succeeded for both ADCS and the Web Server Services. So let me go ahead and click Close. And close out of the Server Manager. Alright, well, believe it or not, that's it. As far as installing a CA, all you have to do is just go through the Add a Role wizard. But to show you that it's installed and to take a look at a little bit of it, I'm going to click Start. And under Administrative Tools, we'll see here that we now have an entry for Certification Authority. I'm going to click that and open up the utility to manage this CA. Let me maximize this. Here you'll see that I've got the green check mark showing me that everything's okay with this GlobalMantix Enterprise Root CA. If I expand this, you'll notice that I have containers for issued certificates, which I haven't issued anybody a certificate yet. Revoke certificates. Here are pending requests if anybody had made a manual request, right, via the web services. And once there are requests in here, this is where managers would go in and either approve or deny the request. And most specifically, here is a container full of templates. And it's these templates that are used for auto enrollment. And you'll notice that there's a number of typical type of certificates that we would have on an internal network that we can use to help assist us with enrollment. As a matter of fact, if you've ever used EFS, the encrypting file system, you'll see here that there's a basic EFS template, and that's really what's used by the operating system to go ahead and allow somebody to get an EFS certificate without ever having to really do anything other than encrypt a file. Now, to manage these certificate templates, I need to go to another utility. So I'm going to click on Start, and in the Start search box, I'm going to put MMC, because the only way to get to this utility is through a custom MMC. So I'm going to select File, Add Remove Snap-in, and here you see Certificate Templates. So I will add that and click OK. And when I click on Certificate Templates, you'll notice that we have a list of templates that we can use to help us create templates to help us roll out certificates. Now, there's one specific thing I want to show you, and that's how to enable auto enrollment of a template. And so if I were to select, let's say this one right here, the computer template, you'll notice right here it says minimum supported CAs Windows 2000. Any of these that say Windows 2000, that means that it's what's called a level 1 template. And guess what? You don't have support for auto enrollment. Now to show you this, I'm going to right click on it and go to Properties, and then go to the Security tab. And you'll see here that there is an enroll permission, but there's no auto enroll permission. If there were, it would be right down here in this blank spot underneath. Now to show you that, let me cancel out of here. And we'll go ahead and we'll pick this OCSP response signing template because this one requires Server 2008, which means actually it's a level 3 template. So I'll right click, Properties, Security, and you'll notice that just like I said, we have an enroll and an auto enroll selection as well. So if we wanted to use this template for auto enrollment, I would have to grant permission to whatever user or groups or computers or whatever the ability to not only read, but to enroll and auto-enroll using this template. So anyway, let me go ahead and hit cancel so we don't change anything there. If we don't want to do auto-enrollment, another way that we can do this is through web enrollment. Now I will show you if I click Start, Administrative Tools, and then go to the IIS Manager. Let me blow this up here. You'll notice that on this particular server, because I said I wanted to do web enrollment, if I expand sites and then expand my default website, you will see here that we have an entry for cert serve. Okay, so we have a virtual directory here for cert serve, and this was designed specifically for the web enrollment. Now to show you this, let me go ahead and close this. Actually, we're done with this as well, so I'll close that. Don't need to save this. Let's go to our Internet Explorer browser and type in http:// New York Mem1 2K8. So the name of this server / cert serve. And this takes us into the web enrollment form. Okay, now on this form, what we can do is we can request a certificate if that's what we're looking to do. If we already requested one, we can look at the status of a pending request. Or if it's been approved, we could go ahead and download the certificate chain, or even the CRIL. So these are the things that can all be done through web enrollment. So let me go ahead and close out of there. And pretty much, like I said, that's kind of it. I mean, most of this interface when it comes to certificate services, it's all about clicking through wizards and following fairly intuitive things. Now, the one last thing that I do actually want to show you before we wrap this up is I'd like to show you the process of setting up an online responder. And I will tell you that it is, believe it or not, a bit tricky. It's not very intuitive. You have to know specifically what to do. So let me show you that now. I'm going to go back to our custom MMC and take us right back into where we were, to the certificate templates. Because in order to be an online responder, well, first of all, IIS must be installed. And of course, that is installed. We've already seen that for web enrollment. Plus, when we checked the box during the role service installment, it would have told us so. But beyond that, the next thing we need is, well, you remember this OCSP response signing certificate template? Well, let me go back into its properties, because it is a requirement that it be configured on the CA with auto enrollment to issue an OCSP response signing certificate to the online responder. So let me go ahead and click add and put in New York Mem1. Let me just check names. Oh, you know what? It didn't find it. And the reason why is because right here where it says object types, it's not including computers. So let's include computers. Now check names, and it finds New York Member 1. Click OK. And I need to make sure that New York Member 1 can not only read, but can enroll and auto-enroll as well. Let me go ahead and click OK. And we can go ahead and close out of this console, I promise, for good this time. So we don't need to save the changes. What I need to do now is go back to, I don't know why I keep closing these things, but I need to go back to my certification authority. Maximize that again. Go to the properties of the CA and go to the extensions tab. Now, again, there's, this is kind of a very specific, you have to do this. You have to include something called the Authority Information Access Extension in order to be able to go ahead and utilize the online responder. So right here where it says select extension, instead of CRIL distribution point, we're going to use the Authority Information Access. And then we need to go ahead, you see here it says specify locations from which users can obtain the certificate for the CA. Well, let's go ahead and add, and I'm going to put in http:// New York Mem1 2K8. Now I will tell you, it's a good idea. It's very good practice to go ahead and put in the entire DNS name, because yes, if I were contacting it from somewhere close by, I could use just the NetBIOS name, but we don't know that that's going to work from everywhere. So let's go ahead and put in NewYorkMember1.globalmantics.com/OCSP. Sensible enough name. Go ahead and click OK. And then we need to go ahead and include the AIA and the OCSP extensions with the certificate. All right, so let's go ahead and do that. We got everything done. Click OK. Says I must restart Active Directory Certificate Services for this to happen. I say, sure, go ahead and do that. So it'll take just a moment while that restarts. Now that it has restarted, what I need to do now is go ahead and expand the CA, go back to Certificate Templates here, right-click, New Certificate Template to Issue. This is where I'm going to come down and select that OCSP Response Signing Certificate template that we enabled for auto enrollment just a moment ago. So I'll click OK. Now the next thing that I would need to do, because this is actually a part of auto enrollment. You know, I showed you how to set it up on the server side, but actually we need to go a step further. We need to go to group policy. So I'm going to minimize New York Member 1 and go to New York DC 1 so we can get to the group policies for our domain. Here on New York DC 1, I'll click Start, Administrative Tools, Group Policy Management. And on the default domain policy, I will right click and select Edit. And again, kind of have to remember where to find this. Well, actually, you could search for it now. That's one of the nice features within group policy. But under the user configuration, expand policies. Inside policies, under Windows settings, I can then go down to security settings. Right down here where it says public key policies, you'll see here that we have Certificate Services Client Auto Enrollment. So I'm going to double click on it and select to enable auto enrollment. Click OK. And then I'm going to do the exact same thing on the computer side. I don't know why I did user first. It's kind of an old habit. On the computer side, under policies, Windows settings, security settings, public key policies, here we have auto enrollment enabled. Okay. And I can close out of here, and go back to New York Member 1. And we have now successfully set up New York Member 1 not only as a CA, and not only as a CA that can do auto enrollment, not only a CA that can do web enrollment, but also as an online responder so as to more efficiently allow clients to be able to validate certificates. Okay, well, at this point you should now know how to describe the different components which make up a public key infrastructure, or PKI, and of course those items being certificates, certificate authorities, certificate revocation lists, and the online responder. And you should also now know how to install and configure the Active Directory Certificate Services role. Alright, well that's all I got for you in this video. I will see you in the next one.